We're going to look at kind of two different vendors and how they like to portray software-defined networking as it pertains to their strategy and their tactical messaging. Okay, so we have some very special guests here. Some things that I wanted to cover just at a high level very quickly is that there is a pretty big disruption coming to the data center. It has to focus on things like on-premises cloud and the fact that for a long time we were very focused on putting things into the cloud, and that typically meant somebody else's infrastructure going somewhere else. And there was challenges around how we connected to those data centers that weren't our own. And now we're looking at, okay, how can I build this same kind of cloud-like infrastructure in my own data center? And in order to do that, I have to be very flexible and agile. I have to automate and orchestrate and all those other fun buzzwords that we love to say. But it also presents new possibilities. And I think that's what today is all about, these new possibilities that we need to capture as technologists, as business persons, as people that really want to change the world in some way and advance our business. I think a lot of this boils down to some conversations we had earlier today around policy-based consumption and creating policy that floats along with a workload, and we'll definitely talk about that in greater detail today. And the design around those workflows. I think Nick Collier had a great presentation around it's not really about automating for automation's sake, but it's around deploying a workflow that can build an application and manage its lifecycle over a long period of time. You can't do that unless you have a network to connect it all together. So today I have the distinct pleasure of introducing you to Joe Onisick and Brad Hedlund, my Daft Punk moderated panelists, whatever you want to call them. And we're going to take a brief little bit of time where we're going to start with Joe. Joe, if you can introduce yourself, kind of what you do, and really around Cisco and ACI's messaging, and I've got your slides queued up here that we can go through.
Awesome. So I'm Joe Onisick, Technical Marketing Engineer with INSBU at Cisco. And what we did when we set out at INSBU to look at and addressing modern networks, the challenges with SDN and what was going on with SDN at the time was try and take a very holistic view of what's happening in the data center. And this wasn't just what's happening right now and what was going on with SDN at the time, but also where the data center is going. So we looked at, from a technical perspective, three major things. And the first one is very simple. Moore's Law is very applicable to the CPU. Continually increasing number of cores and CPU cycles means you can process more on a server. If you can process more on the server, you're going to have to get that data in and out. So that's driving 1 to 10 gig transitions at the access layer, 10 to 40 at the aggregation layer. At the same time, we took a look at the virtualization landscape. Within that virtualization landscape, we found several things, and some of them are non-intuitive. One would be that the densities are increasing, which is the intuitive one. We continue to put more virtual machines on a server. But the non-intuitive ones are the hypervisors being used. More and more, we have 52% of customers worldwide using multi-hypervisor strategies, using Hyper-V or Linux-based, which owns the public cloud space. And then when we look at that virtualization as a whole, that server-based virtualization isn't really the end-all, be-all goal. It's an advantageous way to do things from a legacy application architecture, but when you're building out new applications the way Google does search, or the way Facebook does their apps, or the way the emerging Web 2.0 companies do, they're using things like Linux containers or bare metal servers to do this. And it's the same thing you're seeing with Hadoop. So what we found is that on average virtualization ratios, if you're 70% virtualized today, 90% of your servers are bare metal in your data center. So we wanted to take a holistic view at looking at network and software-defined networking, and we also wanted to address the traffic patterns that are around today. And those traffic patterns are changing. They're no longer the north-south traffic patterns that our hardware and our architectures are built on. They've moved to east-west, where it's 1 gig or 10 gig line rate talking to another 1 gig or 10 gig line rate. So when we looked at this, we realized that if anyone's telling you that you can just slap some software over your existing oversubscribed network today and be good, they're lying to you. There is a change in network hardware, a change in network topology that's coming. We wanted to embrace that while enabling new business models.
Thank you, Joe. And Brad, if you could also answer kind of the same question, who are you, what do you do, and tell us a little about NSX.
Yeah, thanks, Chris. So I'm Brad Hedlund. I'm with the VMware Networking and Security Business Unit, and I'm with the CTO team there, focused a lot on NSX network virtualization. So what we're doing with NSX is what we're really doing is we're helping customers on that journey to a software-defined data center. And the software-defined data center is not a product or a thing and you can buy it and you've got it. It's a journey and it's an architectural approach. So those of you that have been virtualizing your compute with virtual machines, you've already started that journey. So NSX is really the next major piece of that by taking that same operational model change that happened with compute in terms of rapid provisioning, snapshot, clone, delete, right-click, deploy, taking that same operational model and bringing it to the network, right? Just like in a VM, you had vNICs, vRAM, vCPU. In a virtual network, you've got logical switches, logical routers, logical load balancers, and firewalls. And security is a real big part of this. That's why we call it the Networking and Security Business Unit. One of the key use cases that enterprises are deploying with NSX is fine-grained, micro-segmented, zero-trust security in your data center. As Joe just mentioned, a lot of the traffic in the data center is east-west, server to server. And trying to get a hold on the security that's a way that's operationally efficient and cost-effective to be able to secure any traffic and log it anywhere and wrap a fine policy around that is one of the capabilities that NSX has with a distributed line rate in-kernel firewall. So we're seeing that. And then moving forward, multiple hypervisors. You can deploy NSX in a multi-hypervisor environment where you can run KVM hypervisors, ESX hypervisors. So if you're a customer in multi-hypervisors, what you want to deploy, you can put NSX to get that same operational model of networking as you have for the compute. All right? And the second thing is, most importantly, this is all deployable today. Right? Customers can deploy this in production today, and we have production deployments, taking them to virtual networks, automation, and getting towards that software-defined data center. And there's a lot of deep integration with the vCloud suites, for example, like vCloud Automation Center, or on the multi-hypervisor side with OpenStack, so that you can build these templated-based deployments in those cloud management portals and have NSX be the networking endpoint from an API standpoint to rapidly provision and secure all those workloads in the data center.
All right. Thank you, Brad. And I do want to make sure everyone understands that's the last slide you will see. This will be up the rest of the time, so no more PowerPoint. It's always a good one. So I think a lot of good points have been made, and hopefully your brain is stirring a little bit. Let's go a little bit deeper under the covers. Joe, I'm going to start with you. I want to talk about what I'm going to call legacy network design, or let's call it current state, how we're designing our networks today, versus the designs we're looking to do in the future and how ACI will help enable that. Things like on-prem cloud, making sure that we can quickly deploy applications that are wrapped into policy, et cetera.
So if you were to look at the current network architectures, they were all built on the idea of a three-tier design. That three-tier design was primarily based on the fact that the majority of our traffic was coming in from the northbound, being processed by the server, being sent back out. We built oversubscribed hardware. We did services at the aggregation layer for that. The way our applications changed has moved us to the east-west pattern that Brad and I both talk about. And to move the data center forward for the networking perspective, we've got to start looking at different architectures. The primary one that most all of your vendors will agree with would be a spine leaf or a cloth architecture at that point. It's optimized for east-west traffic and the pattern flows that go on in the data center today. It also lets us do a lot of more advanced things when we start to look at going up to a cloud-type architecture, a fully automated architecture, private cloud as I would call it, software-defined data center as Brad would call it. And then in those architectures, we can have everything basically at the same tier. You attach everything to the leaf layer so it's all one hop away. And that would be your WAN connections, your servers, as well as your services, firewall, load balancing, intrusion detection, and prevention systems. And so I think there's really a lot of architecture from the way the topology looks, the way the hardware is built into more non-oversubscribed hardware, and then enabling the services on top in a more automated and programmable fashion. And when I say programmable, I don't mean that you get to go rewrite your applications to understand and provision the network, because no one on the planet wants to go do that. I say programmable in a fashion that the network itself has the ability to consume business-level requirements for the application.
Brad, same question. How are we looking at changing data center design using things like VMware's NSX product and the kind of suite of features that come with that to change our traditional design around the network to kind of an on-premises cloud-type design?
Sure. I mean, I think a lot of customers are deploying NSX and the SCDC on a variety of different network architectures, the ones that they already have in place with their existing Nexus 7000s and UCS. We're seeing deployments like that, as well as the new types of leaf spine architectures Joe mentioned. I mean, that's the thing. You can architect your physical fabric in a number of ways. I think one of the big changes we'll see is how services are deployed, right? Like firewalls and load balancers. Typically, you've got these big pieces of iron with 10 gig interfaces, and you hang them off some port on the core switch, and your job is to shove all the traffic through those appliances and get them back. Things are changing now. You have an in-kernel distributed firewall with NSX. You can do firewalling right at the VNIC of the VM, right? Rather than having that big piece of iron there. And load balancers, for example. We're seeing load balancers deployed, as VMs, right? Programmatically, so that you'll have this compute layer with NSX and network intelligence in there in terms of firewall routing and switching, as well as load balancing, so that kind of the network fabric is very much an IP transport with not a lot of boxes hanging off, the core that you're having to deal with and orchestrate and shove traffic through. Bless you.
All right, thank you, Brad. So I think you bring up a good point. We're talking about within the data center, as far as firewalling goes, we do typically have a lot of zones or segments or whatever you want to call that. Joe, I'm curious, within an ACI solution, how do we accomplish kind of that more in-path firewalling? How do we get rid of the need to segment the network into chunks and have firewalls in between them, specifically around an ACI design?
So again, I think we really looked with ACI as a more holistic approach. We realized that as Brad says, distributed firewalling, distributing load balancing within the hypervisor is a fantastic way to go. It's great for the edge-based policy and edge-based security. At the same time, physical appliances are still going to be required in some cases, and they're still in your data centers. So we didn't take a very myopic view and say everything's going to be virtual. We said let's embrace the virtual and the physical as well. Let's automate all of these layer 4 through 7 service appliances, whether they're virtual or physical, to put them in the path. And let's go ahead and not take the view that Cisco owns the entire world and make you buy all Cisco appliances. Let's embrace an open architecture that lets any layer 4 through 7 appliance plug in from any vendor. Then we took security a little further down into the ground level, and we said, why shouldn't the network at a line rate in sub 5 microseconds from any port to any port act as a stateless firewall on its own? So instead of having a network as you design it today where it's all wide open until you decide what to close off, why don't we provide the ability for you to do stateless inspection of every packet at line rate on the hardware as well, as an added benefit of being able to secure and provide policy across the network?
Can you talk to kind of the strengths with the solution within NSX so that maybe perhaps programmatically, possibly automatically, we can create workflows that will help spin up and down networking within the product?
Yeah, absolutely. I mean, I think you can take two different approaches. You could do more of a self-service data center automation approach where you're going in, you're pointing and clicking and creating firewalls and load balancers, logical switches and routers, and you're tying those together using familiar networking constructs that you're already used to. Or you can look at it from a higher level orchestration perspective where you create generic application templates. Now, this would be a consumer-facing interface where you're not exposing all of the nitty-gritty details of firewall interfaces and VIP IP addresses and load balancers. Very generic template, web tier, app tier, I want some security, I want some load balancer. So that's what your developer wants to consume, a self-service portal. So that would be like vCloud Automation Center. And there's that integration with the vCloud Automation Center into NSX so that once that template is deployed, we know who deployed the template, and we can wrap policy around that. And NSX will provide all of the networking functionality to fill that template. And the best part of it, too, is when that workload is removed or destroyed, all of that security policy goes with it, right? You begin to get to a world where you create policy around abstract objects like groupings of VMs. This developer deployed these VMs, and they can't talk to these production VMs over here. And when those VMs go away, the firewall rules go away. Nobody's trying to translate what specific IP addresses were deployed and how do we delete those rules out of the firewall. Well, I won't touch it, I'll just leave them there. And 2 or 3 years later, you've got a firewall with 15,000 rules, and it's a big complex mess. So I think it's the destruction of the applications and the cleanup afterwards is one of the things to that, or I think it will be beneficial with those type of approaches.
Certainly. Joe, I'm curious, from your perspective, when we're talking about, to use your word, Brad, destroying workloads that have a short life cycle, how do you think that plays within the architecture of Cisco's ACI?
I think we take a very similar approach from some of the concepts Brad talked about. Everything within ACI is deployed as an application network profile. It's an XML or JSON representation of the end-to-end application policy and the groupings of objects, virtual and physical objects that make up that application. So within that profile is much like a UCS service profile if you ever use the UCS system. We deploy it onto stateless hardware. We deploy the rules within virtual or physical layer 4 through 7 devices. We remove them or apply compliance and auditing based on that application basis from that profile. And to create those profiles, they can be done manually through within the system via our RESTful API. They can be done via the GUI or the CLI. Or more importantly, they can be shared amongst the community. They can be published up through CloudStack or OpenStack, our partners. You can use Cisco automation tools to provide an interface into using those. Or your application vendor can give them to you. So in the instance of SAP HANA is a 2-year deployment cycle from the time you want to get online with HANA to the time it's deployed, because it's a very complex ecosystem. Instead of that, with ACI, you can import an application network profile that SAP's developed using all of their recommended practices and have that service deployed with all of its end-to-end connectivity and policy requirements in minutes. So I think we take an approach that allows you to abstract away how the hardware is implemented based on a logical definition and apply it to any hardware you choose.
So as we build these abstractions and as we fundamentally change the workflow that the business is using and the IT is building, how does that change the various teams, the skill sets? And there's a lot of fear, I guess, that I'd like to hear addressed around maybe the network engineer going away, that kind of FUD. Brad, can you speak to that within the realm of maybe VMware NSX?
Well, I would say this is a very critical time in the career of a network engineer. I'll just be flat out honest with you. I mean, now is the time where some folks are going to refuse to go, and some folks are going to raise their hand and say, I get it, I want to do that. I want to. It's just like very similar to the ESX days in early 2000. One guy back in the room said, I'll try that, and look where they are now, right? So NSX is there as a standalone product. It's independently deployed, and there's keys to a virtual network that underpins a software-defined data center. Now I can give those keys to the network guy, I can give the keys to somebody else. They're there to be grabbed and to take. This is not about the server guys taking over the world and no thanks network, we don't need you anymore. There's still a job to architect and troubleshoot and manage, this virtual network, and somebody's going to do it. And there are going to be different tools. There's going to be different ways to troubleshoot and monitor how networking services are deployed, right? And somebody has to learn those. So I think this is a time where that kind of that stale, mundane VLAN config career path that they've been on for the last 5 years, nothing really interesting. You can kind of stay on that, and that'll last probably another 5 years or so. But now's the time to really, just like the server guy turned into a VM admin, turned into a virtualization admin, turned into a cloud architect, I think the network engineer is in that inflection point right now.
So Joe, I'll take a similar vein as what we talked about in that previous question, but I want to twist it a little bit for ACI and perhaps get your opinion on moving forward. If I'm a network engineer or I'm some way related to that process of networking, that workflow, what do you think would be some good skills to start honing, some things that you feel would be advantageous as a network engineer to start focusing on, especially when I want to start working with Cisco's ACI product?
So if you're a network engineer and you don't want to become a developer, you're out of a job. Okay. Sorry. No.
And that's it.
But in all seriousness, there's a great quote, if you don't like change, you'll like Relevance Less. It's from General Shinsneski, who's running the VA right now, or actually just resigned from running the VA. It's a great quote nonetheless. But the idea is one of the things ACI really does is provide you tools, visibility, and configurability in a fashion that makes sense to your job. So if you're logged in as a developer, you're going to get relevant information, relevant deployment tools because you're a developer. If you're logged in as a network engineer, you're going to get relevant tools, relevant configuration because you're a network engineer. What will make a lot of sense for network engineers moving forward, and I think it's from anybody's perspective, is understand what an API is and what an API offers. Understand some basic scripting languages to a very light extent so that you can utilize an API. You'll find that by learning a little bit of scripting, you can do a 30, 45-minute task in 30, 45 seconds. So advancing some of those skills and understanding a little more of the policy required when an application gets deployed. And I don't mean how an ACL looks in a firewall or how a rule looks in a firewall. What's the actual business policy required for that firewall rule? Understanding a little bit about the compliance, the security, and the governance that actually is required by the application so that you can tie those two languages together a little more closely.
So let's take one kind of logical step back here. We've talked quite a bit around kind of what you need for the future, how these things are going to change your data center. But we haven't really addressed, and Brad, I'll start with you on this question, kind of what is the need for this change? Because in a lot of cases, I would assume things are working okay today. And so there's got to be a driver to actually disrupt the data center and to incorporate these new products and to change the workflow. So Brad, I'm curious, what kind of drivers do you think would motivate a customer to want to adopt something like NSX?
Yeah, I would say, as I mentioned earlier, security is a big thing in that, right? I think we can all agree that there needs to be more security control in the data center for the applications. So we have customers that are looking at NSX for no other reason than just the security controls that I mentioned, having that distributed in-kernel firewall and writing firewall rules on abstract groupings, dev VMs, prod VMs, and not IP addresses. I think that's one very good use case. But I think also too, enterprise IT, the leaders of the business want their IT to be more like Amazon or be more like Google in terms of agility, speed and efficiency, price performance, right? So we're seeing that too, and I think IT is in an inflection point right now. You have the tools now to make your IT more like Amazon, more agile, rapid provisioning, providing a quicker, better, cheaper, faster service to the lines of businesses. And I think those that are really feeling the pressure to compete in terms of IT with the public cloud providers, we're seeing a lot of traction and interest from those customers as well.
Joe, could you provide your thoughts on that same process around what would be a motivation within my data center to make a change? I mean, specifically around ACI, but what kind of pressures are being placed upon the networking team, the data center team, et cetera, where this software-defined networking thing is going to be critical in the future?
I think overall in the data center network especially, we hit critical mass of complexity. Who in the room is a network-focused engineer, architect, technologist? So for 30 years in that field, we've been MacGyver. We got hit with a point problem. We looked around the room. We found a Swiss Army knife, some duct tape, some bubble gum. We fixed that point problem and moved on to the next one. And now if you take a step back and you look at your network, it's all Bondo and duct tape and bubble gum holding that thing together. When you need to deploy a new service, you need to deploy a new application, you've got a series of devices you got to go configure. You got to look at what somebody did last year and, oh, by the way, they quit, so that you can't ask them why they did it. And we have all this complexity that makes it slow to change, slow to adopt new services, slow to compete in our industry, and slow to deliver new services to our own users. And I think that's where the precursors to ACI, like Generation 1 SDN solutions and ACI really go, is to try and fix that complexity, speed up the way in which you can operate that environment, but you also need to be able to do so without just increasing the fragility. You don't just want to take the same complexity and automate it, because you're just going to speed up the chance at which something's going to break.
So Joe, I like the fact that you used the bubblegum, Bondo, MacGyver type construction materials as we talk about the network. And I think that's critical that we have a solid foundation before we try to apply any kind of policy, before we try to build any kind of workloads. Brad, could you discuss perhaps how critical it is with NSX to have that underlying infrastructure at a certain state or a certain health or perhaps a certain amount of performance, and perhaps how that's going to be influencing an NSX design?
Yeah, absolutely. I mean, hardware has to be there, right? We don't deny that. I mean, you can't run a virtual machine without a physical. There's a hardware requirement for ESX to run a physical server. Same thing with NSX. There has to be a physical IP fabric there. So we're seeing customers deploy, robust, highly available fabrics from wherever the favorite network vendor is, probably Cisco, right? So you still have to build a good fabric, right, with redundancy, plenty of bandwidth, low latency, and there's a lot of good equipment on the floor today that you can do that with. Nexus 7000s, 5000s, UCS, for example. But also, what we're not saying here is because all of the intelligence is now in software and snapshotable and templatable, that doesn't mean that you can build a cheap, kind of dingy physical network, right, with D-Link switches or things like that. Absolutely not. We would recommend that. You still have the responsibility to build a physical fabric, right? So I think, that there's a lot of different ways to do that. Leaf spine architectures. I actually think, the Nexus 9000 is a nice, cheap switch, fast bandwidth. Anything, Joe, to agree with that. You can build a good fabric with the Nexus 9000 and deploy NSX on that, right? I think we'll actually see a lot of deployments like that.
So Joe, I'm curious, since we've been talking a little bit about the infrastructure and you kind of spawned this whole discussion around the duct tape piece, how important is it in an ACI design? And also I'm very curious, what new topologies I need to construct in order to take advantage of ACI, because I've heard about an APIC and some controllers and all that jazz, and I'm curious how it all blends together in order to build an ACI-powered or ACI-fueled data center.
Excellent. So we've taken a much more balanced approach, I think, than any of the solutions out there today. We look at both hardware and software as solving portions of the problem. It's all driven by our two engineering leads. So NCMA's chief scientist and co-founder, Mike Dvorkin, believes that every problem you can come up with, he can solve in software. NCMA's CTO and co-founder, Tom Edsel, has been designing switching ASICs for 30 years. He's been solving very difficult problems in hardware ASICs for 30 years, and he understands that there's some things you can't solve in hardware, like jitter and latency, line rate performance, and security. So the two of them work together to build out where is the best fit for the hardware, where is the best fit for the software, and combine them together, much like was done with UCS. At the same time, we know that you have a large investment in existing network hardware and existing topologies, and we're not naive enough to think that you're going to go rip and replace all those today. So we have a model that uses them both together very well and gives you the best possible advantages while being able to insert over that current 5K, 2K, 6K, 7K architecture. And so we've got a very balanced and transitional approach to how you can take ACI into a data center that you have existing today.
So Brad, earlier in our conversations, we did kind of mention the fact that there's north-south traffic, there's east-west traffic, and in my mind, as kind of an environment across the globe, we've shifted traffic a little more east-west. We're kind of evacuating from that north-south model. So tell me some ways that I can further enhance my data center for that east-west traffic and make that more of an optimized data flow with something like NSX.
Yeah, I think it goes back to security again. I'll keep mentioning that, where a lot of east-west traffic traversing tiers of an application, for example, or maybe going from one environment to the next, you want to be able to secure all of that traffic. And at this point, what you tend to do is build these trust zones, which translates to a VLAN. And you try to micro-segment all of these zones with smaller and smaller VLANs and shove that traffic through these firewalls. So what was all east-west traffic is now being really hairpinned into north-south traffic again, which creates performance bottlenecks, costs, and operational challenges, right? You've always had to make the decision, do I want performance for this east-west traffic, or do I want security? Right, so now, really, with the firewalling happening in the host, in the kernel, in the hypervisor at line rate, attached right to the VNIC, you really don't have to make that compromise anymore. You get the security on a per VM basis, stateful firewalling with logging per VM, and you also have the east-west traffic taking the most optimal path from one point to the next, right? So I think, and as you add compute, right, if you've got a cluster of hosts, and you say, I need to add some more compute to build out the work. As you add that next compute cluster or host into that cluster, you have, by definition, added more firewall, because the host with its kernel firewall is a firewall as well, right? So the security capability scales out with the compute at the very moment that you add compute. So I think that's going to be a very compelling use case in terms of addressing east-west traffic in a data center. Getting rid of these big tiers of firewalls, these big pieces of iron that you have to shove traffic through, and really, is a challenge to deploy those from an operational standpoint, from a cost as well.
So Joe, I think recently IDC announced that Cisco UCS, from a blade perspective, Blade x86 blades is the #1 compute platform in the North Americas, which is pretty awesome. However, in my mind, UCS was designed, optimized for north-south traffic. It can do east-west, but there really was kind of a topology of that north-south traffic. Is there a way I can leverage ACI to kind of go against that grain a little bit, or help enhance the topology of UCS to make it even better than it currently is?
That's interesting. So UCS itself is interesting. That server platform came out 5 years ago. It walked into HP's campus cafeteria and has been eating their lunch ever since. And you're right. It was designed on a more north-south traffic pattern. It's a layer 2 infrastructure where you go up to the fabric interconnect for switching. Now, from a latency perspective, going up to that fabric interconnect from any port to any port on any chassis is consistent latency and actually better than most other blade chassis out there, even when they can switch within the chassis. But that being said, future generations of UCS will be based on, the fabric interconnects will be based on Nexus 9000 hardware. Layer 3 capabilities will be added in there. So not only do you get that consistent latency performance, but you can now have your layer 3 policy boundary. The reason it was designed that way in the first place is because we were pushing layer 2 at the edge, because we had to have layer 2 for vMotion, and we were using heavy server virtualization with vMotion. So now that is changing, and we have layer 3 vMotion and virtual motion or virtual machine mobility capabilities, we're pushing the capabilities into UCS as well.
I just have something to add to that real quick.
Feel free.
You guys go to vmware.com/products/NSX, and then you click on technical resources. You will see a white paper on deploying NSX on Nexus 7000s and UCS. Right, so I won't go through the whole white paper now, but just make a note of that and read it tonight.
Brad did a very good job with that white paper, by the way. I will have to admit that.
Thank you, Joe.
It's the only time you'll ever hear a compliment going east-west like that. So as we kind of wrap up this discussion, I think it's important to note that, and I think this was discussed a little bit earlier, but we're not just looking to automate for automation's sake or orchestrate just because we like orchestrating. We're not looking to put in ACI or NSX just for the fact of it makes life a little bit better. It has to make it a lot better. It has to make the business run a lot faster. And so I'm curious, looking at if I were to deploy one of these products, and Joe, I guess I'll start with you. If I were to deploy ACI, what are things that I could do with ACI that just is not possible or extremely difficult if I were to try to use today's kind of, well, let's say, legacy or standard topologies in infrastructure and hardware?
Well, as soon as you deploy ACI, unicorns and rainbows start shooting out of your data center, which I think is the most important part.
Okay, we checked the box for rainbows, got that.
But so the idea, and I think it's kind of on both sides, the idea is to be able to deliver new services faster. With ACI, we take a very application-centered view of it. We want to deploy an application, give visibility, auditing, and governance based on that application or service being delivered. Do so in an automated fashion. The reason we want to do so in an automated fashion is not just to speed up how fast you can do things, but automation primarily reduces your risk. If you take a task, you test it once, you make sure it works on one device or for one app, and you repeat the process, you can assume that it's going to work each and every time, reducing the risk of human interaction with multiple different devices. And we can deploy those services more quickly, which is important for two reasons. One, you've got competition or a mission to accomplish. You've got to compete with your competitors in your industry, deploying new services and new revenue generating streams. You also have to be able to compete for your own users today, which you didn't used to have to do. If you can't bring a new service online for your own internal users, they're going to go swipe a credit card with Dropbox or with Amazon or with somebody else, and you're going to lose every bit of possibility of governance, security, and compliance around that. So we want to be able to provide application agility. We want to be able to allow you to deploy the services your business requires as fast as possible, maintain governance, compliance, and security across any piece of hardware, whether it's virtual or physical.
I think there's a car commercial where it shows how fallible we are as humans, like the tree runs on a car's hood or something and the guy backs into his driveway. So I think the risk point is well received, the fact that typically a person will be fallible 1 time out of 10 or more. Whereas a computer, hopefully if we've coded it right, won't mess that up. Brad, I'm curious, what kind of risks can we alleviate by incorporating something like VMware's NSX in any way, shape, or form in the data center, whether or not it's the firewalling rules or creating logical switches and routers or whatever pieces that you want to discuss?
Yeah, I would say, imagine if you could take every VM in the data center and connect it to its own port on a firewall, right? I mean, that's always been the dream, the nirvana of every security guy. He wishes he could connect everything to the firewall, and the whole data center is just this one big firewall, right? Firewall is the core of the data center, but it's just been cost prohibitive. It's been operationally complex and just infeasible. So that's really what we're allowing you to do with NSX that you've just never been able to do before, is to take every VM in that data center and have its own port on a firewall that's transparent. You're not putting the default gateway of the VM as the firewall. The VM doesn't see anything, and it's a logical object of VMs that can be dynamic, right? So like if you're at a cloud portal and you're saying, developer A is going to deploy an application. As that cloud portal deploys those VMs, it can put a tag on those VMs that says developer. Meanwhile, the production workloads have a little tag on them that say production. And then the firewall looks at those tags and builds the policy around that, not around IP addresses or not around picking a port group, making sure the vSphere admin picks the right port group. And only if that happens, then you'll get security. That's not the case here. It's automated into the platform at the very edge of the workload. So I think, I know I'm harping on security a lot. I think that's really kind of the big pressing issue that customers are looking at to address in their data centers, and I think NSX is squarely positioned for that with its capabilities in firewalling.
So as you were talking, Brad, I kind of formulated a follow-up question because you've mentioned quite a few times that we're working kind of at the granularity of the virtual machine or the virtual machine's network adapter, the VNIC. But what if, and I assume most of us don't have 100% virtualized data centers, what if I do have a portion, a minority or a majority of my workloads are running on physical servers? Does NSX still make sense in that case? Can it talk to physical and virtual? How does that work?
Sure, absolutely. So you can take that physical machine, which has an IP address, right, and you can put that IP address into the NSX firewall constructs as a group. You say, here's the database server for this app, and here's the IP address. It's not a VM, it's a physical. And the rules in the firewall can use that to populate the rules across all the VNICs. So typically in an application, it flows through tiers, right? It goes through a web tier, which is VMs, goes through an app tier, which is VMs, and then it might hit a database tier, which is physical, right? So as soon as that app tier VM is going to try to send traffic to the database tier, we can protect it right there. If that physical machine is sending any traffic into the virtual environment, we will filter it right there. So as long as there is a mix of virtual and physical, and that's part of an application, we can definitely address that. Now, if your application is just all physical machines, then I would argue you don't really need NSX for that application, right? I mean, I'm not telling you to rip out everything in your data center and put in NSX. You're going to put NSX where it makes sense, and that's where you have applications that have been virtualized.
Joe, did you have a follow-up to that?
Yeah, I would say I agree with the security.
You look kind of fidgety there. So.
Yeah, didn't want to interject. Yeah, I would agree with what Brad's saying as far as security, and we take the same stance as that idea of being able to secure everything at the edge and look at the network as a large firewall. We just take it a step further and incorporating physical in a completely transparent fashion as we do virtual machines, rather than needing that requirement to go into the virtual layer for everything. And that ties into your layer 4 through 7 devices, whether they're virtualized in a distributed fashion inside the hypervisor or they're the physical appliance you already invested in.
Okay. So as we're working towards the last couple minutes here, I was just hoping that, starting with Brad, if you could give just a couple words around next steps, what you think would be some good advice as we kind of leave this next generation networking panel that can be left with the audience in 30 seconds or less. Go.
Yeah, absolutely. I mean, I think you should be looking at what the capabilities of NSX are from a security standpoint, from a network virtualization standpoint, and even if you don't do a proof of concept in your environment, we have our labs out there that you can log on right now, labs.hol.vmware.com, and you can get a feel of what this platform looks like. How would I actually operationalize this, right? And try it out. And you can start very small. You can pick a couple of servers in your existing facility and create that as a little NSX sandbox, right? And get operationally comfortable with it. I don't want you to put anything into production that you are not operationally comfortable with, because you're going to fail, I'm going to fail, it's going to look bad. So I would say get started now. Even if you think, oh, I'm not really going to deploy this maybe for another year, you should be getting started now just to get operationally comfortable with a new way of managing networks. And whether it's NSX or whether it's ACI, you should be getting started now, looking at both.
I think that's good advice. Never put anything in production you don't feel comfortable with. Joe, do you have any words of wisdom to part with here?
Yeah, I would say if you're looking for more information on ACI, start at cisco.com/goaci. And then the one other thing that you won't be able to find on our public website, talk to your partner here at AHEAD or talk to your Cisco reps and find out about our pricing. Coming from a Cisco perspective, you're going to love it. It'll surprise you.
Okay. Thank you guys very much, and I appreciate all the audience participation and you listening in and after a sleepy meal and all that good jazz. So thank you very much.